I said, I'm based outside Dallas. I actually have my wife's family's from Birmingham, and out of the Birmingham area, and then out to Rainbow City and Gadsden. So we've got at least half my family. They're a good mix of Auburn, Alabama fans, so it's okay. If you have any questions along the way, don't feel free to chime in, because I think it's a lot easier. There's a lot of code, so it's a lot easier. If you have a question, go ahead and ask, because that way we'll be right there looking at the code together. Let me move this over so it looks like I'm actually looking at you. There we go. You can find pretty much on GitHub, anywhere, pretty much P. Kinney. I've got a bunch of geospatial packages and Elixir. Those are the main focus for a while. I'm also on the Elixir Slack as P. Kinney as well. And right now we're for Vancor. Like I said, we started off in the IT space, but we still build hardware and software. Still kind of doing the same kind of skill sets, but just applied it to some new opportunities we found to expand into. But most relevantly to this talk, we've been doing Elixir since day one. We're doing LiveView since day one. It's been, a few times in your career, you get to start a couple things fresh and get to kind of pick the technologies you want. And this was a good opportunity to do that. So originally, I think back in August or so, when I was asked to talk, we just finished working on this awesome file upload for LiveView. I was really excited to share it. And then days later, Chris McCord tweeted out that there's one coming. So that was an awesome talk. This is the second place talk. So just imagine that would have been a really good talk. But I think really what I want to settle on was, OTP by name of their name. In other words, my goal here is to demonstrate that LiveView being closer to what makes Erlang OTP great. Understanding LiveView is not just an extension on top of Phoenix, but as exposing OTP directly to us and allowing us to build better user experiences. What can we do if it's easier to work in a stateful web environment? Which to me, and it kind of my proposal for this talk really is that LiveView makes it easier to do stateful than stateless. And that allows us to do a lot of things that we otherwise would have been wrestling with a stateless environment to provide that stateful-like experience to the user. I would assume most everybody probably knows what OTP is. Just in case they don't, this is just the quote out of Francesco's book. It's domain-independent frameworks, principles, patterns, guide to support structure, design, implementation, fluid systems. The important thing is it's not just this library. It's not just a set of tools. It's actually the patterns we use to build on top of Erlang's VM and to use it to its best ability. And in the same book, he actually has a good diagram kind of showing what I call the bottom of the iceberg for everything that we don't have to deal with, thankfully, when we're building on top of Erlang. And if we look at Phoenix as you're just approaching Phoenix, especially someone coming from another framework, this is sort of what it looks like. There's Phoenix. It's obviously using the underpinnings of OTP. It's doing great things for scale and everything else. But there's a layer of that MVC abstraction that most people start building their applications on top of. So it's the same thing, like a Rails approach, right? It's a layer of MVC abstractions you can build on top of to build your stateless application. And there's nothing wrong with this. The abstractions are extremely useful. It's really great to work with, even if you're just living in that MVC world. There's obviously still channels. There's other ways you can interact. But when most people start out coming from something like Django or Rails, the familiarity of the MVC abstractions make it easy to get started. Underneath the covers, Phoenix is making it so that application you build is super scalable. It's using those soft real-time characteristics of the VM to greatly improve the user experience, but still allowing you to live in that stateless web world. You could do a lot more, obviously, using channels, and then now with LiveView. And in fact, when we started using LiveView, we kind of did this hybrid approach where a lot of the application was still a standard MVC application. You were going to pull up a table of, for instance, in our example, we were using sensors. We had a table of sensors that were just served over regular HTTP. And then we interspersed within that or sprinkled little LiveView in certain places on that where we wanted to see the sensor value change in real time, for instance. We found it a bit tough actually to straddle both approaches, trying to develop features that operated in the both stateful and stateless context. It probably caused more cognitive load on the developers than was really necessary. And there were things like authorization, which behave very differently when you're in a LiveView in a stateful environment than the stateless environment. And so we kind of had to have two models in our head of how authorization works, or two models in our head as far as pagination works. Things like that, that you just have to keep both in your head if you're trying to do both. And so we realized we could really do everything we needed with LiveView. And so most recent application, really, we've only been doing LiveView. In fact, the only controllers we really have are for external APIs. I think we did some stuff for authentication, but we'll get into how we've been able to get past that as well. Which is great. We get to operate in that OTP land from the top of the stack all the way down to the bottom. That process-driven approach. I think I didn't realize this is the book that's actually given away today. That was a coincidence. Functional web development. So this book is really based around building out this application kind of throughout the book. The first half, I guess, maybe third half, is just working on an OTP under an umbrella application, working on an OTP application that works on the business logic. And when he gets to Phoenix, he has this great introduction that basically says, Phoenix is not your application. You're not building a Phoenix app, you're not building a Rails app or an Ember app. You're building a business application that does a thing for a user. And this happens to be the way you're interfacing that user with your business logic. And he talks a little more about the problems around getting locked into a way that an ORM, for instance, in their example, makes you think about solving your business problems versus solving the business problems and then having those tools on top or tools underneath it to help support that. Along the same lines, about this time last year, I got to speak at the Big Elixir in New Orleans, and I presented a project I built on Scenic and Nerves. Scenic is a client application. It's really an application library. It lets you build native-like components in Elixir on top. Usually, it doesn't have to be on top of Nerves, but it typically is working in the Nerves on a Nerves application. And it's really designed for fixed screen devices. So in this situation, it was a sprinkler system that I was working on. It was just a Raspberry Pi screen. But one of the big things that I talked about and I kind of learned from this project was the statefulness that OTP provides makes interacting with these real world actors much easier. So things like modeling a relay, I know that my actor within the system, my process that represents that relay is connected to that relay in such a way that I know that the state is represented in my application the same way as in the real world. And those state changes that I would do, like closing the relay, opening the relay, resetting the relay, things like that, are all modeled exactly in the sensor state within the application as well. Each of the virtual buttons, the UI elements on screen, all those are modeled as actors. They all have their internal state, and they all have message handlers. And that's kind of at the bottom. You can see some of the code. Take a look at Scenic if you haven't looked at it. It's a great library by Boyd M. But it's the same thing. It's still dealing with a actor receiving messages. It just so happened that when I was building that project, it coincided with when we were really starting to get into LiveView applications. And I realized what makes the Scenic Nerves so much better to build with than a typical embedded framework or a typical embedded UI framework was the same thing that really makes LiveView such a joy to work with, which is that everything's an actor. Everything has state, not just state, but explicit state, states you can easily introspect into, whether it's within the application or use an observer, things like that. The same way that I was looking at my model of my relay in the observer in IEX is the same way that I look at a LiveView now. You're able to look at this and see that same actions going on, and a deterministic way of modifying that state. You can't, when you're working with a gen server, for instance, or working with LiveView, you can't really avoid the state because you're always having to deal with it. It's always being passed to you. Every handle info, even the structure of those calls is designed to make you have to deal with that and know it and introspect it. And just to pull from LiveView's documentation, it's the second paragraph. At the end of the day, LiveView is nothing more than a process, and that's it. And so we'll get into a little bit of that. Stateful, nothing more than functional. There are events, either internal application messages or sent by a client browser. Now, there's actually, we'll show kind of doing even more than that and ways you can use this process in a second. The nice thing is that, as opposed to just using plain Phoenix, you had a new DSL to learn for building MVC applications, but there's nothing really particularly new in LiveView's lexicon above what you would already know with OTP, or at least those patterns. So the central focus, what I want to kind of talk about now is there a way to take the stateful nature of LiveView and enable better user experience for the end user? Pretty much I would argue that pretty much everybody, unless you happen to be a real big Roy Fielding fan, wants stateful experiences. Almost all non-digital interactions that users go through every day are stateful experiences. When I have a conversation with somebody, I don't have to, every time I want to speak, present my session token so that they can go look it up in their book to see where we were in a conversation. These are almost everything we do is stateful. Even the machines we work with, we're working them in a stateful way. And I think as developers, we spend a lot of time, a lot of effort slathering on layers of stateful paint on what in the end is a stateless API or RESTful API. So I've got three or four, depending on how much time we have. Oliver or anybody can feel free to yell at me if we start going too long. I would show a couple UI actions that we're all kind of familiar with, but a way to do them inside of LiveView. Maybe ways that make them either easier to work with in some situations or even just better for the user because we're able to maintain that state. Any questions so far before I kind of go into the examples? Okay, perfect. Or someone's scrambling for the mute and it's too late. So I think the simplest stateful interaction would be something like a wizard. So you've been in a situation where you need to use one user interaction to build a couple of dependent entities. In this situation, we're looking at the sign up. If I want to sign up for a new service that maybe is a multi-tenant service, typically you're going to ask someone for their organizational information so that you can create the organization entity within the system. You can ask them for account information so you can create a user entity. And it doesn't really do you any good if one of those gets created without the other. And so you might walk them through a wizard like this and in the end push that to a transaction. And typically there's a lot of really gnarly ways to try to do this in a typical application. I don't know how many gems there are in Rails on how to do a wizard, but it gets very, very complicated. And this is something that just having that state with the user makes much, much easier. Just to get started, so here into the LiveView code now, this is LiveView. When we're mounting that LiveView, and actually, can you guys see my mouse?
Yes.
That'll be really useful. Okay, good. So all we're going to do is set up a couple things. One, we're just going to keep track of what step the user's on. And then there's two change sets I'm trying to do. So I've got to hand change sets to the forms. There's only two. I need an org and a user. So I said create some empty ones here, assign them the socket. And then this is big. I'll zoom in because really the important part is the render function. In this situation, I'm matching where I am within the wizard to decide how to render. You can do it probably cleaner other ways, but there's a real clear way to do it. I've got one form here. If I'm in the org step where I have a form for the org change set, I have a validator and a save that's specific to the org. When I get to the user, same thing. I'm matching for that step being user. I've got a new change set, do validation and save events. And then finally, when we're complete, we'll show all done. And the handling of the validations is the same as any other examples you might see. We're gonna make a new change set based on the parameters. We're gonna return that back so it can display the errors. But the important part comes when I try to save the org. So remember doing the organization first, then the user. And the organization, I'm gonna assign, and this is assuming I do some validation here, make sure that's valid first. Once I know those parameters are valid, sorry, I'm going to stick those org parameters into my state and assign the step to move to the user. So I'm moving that to that next step. And finally, the last part, as soon as I save the user, I'm going to use, behind the scenes, I've got a ecto multi that's doing the transaction. And out of that, I'll get an error depending on which of the models I try to save has an issue. And then finally, if it works out, great, we'll go to that complete step. And so let me switch over. Let's make sure this works. So here is that form. We are in that organization state, and I can type in, I'm getting that validation on the organization's validation. So let me put an organization in here. I can put, I used to work with a guy named John Sample, and that's now the name that I use for all of these. And sure enough, I've got the organization, I've got the user, hit sign up. Oops. Well, that was my demo. I guess I didn't clear that. Let's do Acme 2. And you're probably going to yell at me too. Okay. So there we go. So we created the organization, the user. And now you've already seen the big reveal, which is the one thing this lets us do is if I type in something that I've got a validation right now on the database that Ecto is aware of, saying how the organization name has to be unique. I know I have an Acme Inc. in there. So if I try to enter someone else here, let's do, it's actually going to run into this, that it'll try to save it. The multi will come back with an error on the org. Give me that change set. I'll know there's an error on org change set. So I'll go back to that step and show the user, hey, by the way, this name's already been taken. Okay, if I correct that, I go through, everything else is fine. Oh, that's right, I already have this one too. Let's make 2 and sign up, and that's it. So again, it's doing this in another framework where I'm trying to maintain, you're trying to make that different routes, different ways into the controller can be really, really complicated. This does everything the user expects it to do, but because we're able to keep that state open throughout the whole thing, I'm able to do it in a much smaller amount of code and a much cleaner, easier to read way of handling it. So that's one out of the way. The next one is login, and actually specifically the exponential back off that we wanted. So most, the best practice of if someone logs in, they get their password wrong, you want to exponentially back off to kind of thwart any kind of brute force attack on a password, right? Slowly increase that time. So if I log in with the incorrect password, it comes back immediately, says, oh, that's the wrong password. I do it again. Maybe it waits 100 milliseconds. Maybe the next time it waits 200 milliseconds, next time 400. And eventually that exponential back off will make it where it's just not effective for me to keep trying passwords if I don't know. Typically, you might have a sleep in the controller where I get call to get that post from the form. I wait some amount of time before I actually respond. And that works well against the attacker, someone who is just looking at those responses. But for an end user who's maybe going, this is kind of frustrating. They don't know why is it taking longer? There's something wrong with my browser. I know this is my password. That's the 5th or 6th time I try to type it in. Or maybe I'm one of those people that has 5 passwords. I only use 5 passwords. I'm trying to type it in. And I'm just getting no response back. I'm getting no feedback as to why it's taking longer and longer. And it's just it gets frustrating. So let me show that demo first. It'll make a little more sense. So if I try to log in, the wrong password, oh, you go away. It's going to tell me wrong password. So I try it again. Still wrong password. Keep it here. And it's going to wait 1 second. Now it's waiting 2 seconds. Now it's going to wait 3 seconds. And you'll see it eventually just becomes, once I finally get the password correct, and so everybody knows the password is 1, 2, 3, 4, 5, then it's still going to wait those 4 seconds, and then it's going to let me in and reset everything. But that whole time I maintained that interaction with the user. And this may not be the best example of when you want to use it, but it's important to realize that using something like LiveView, we can actually maintain a timeline within my interaction with the user. So it's not just a call response. I can actually do things with the user that are specific to the time in which they're going on. And LiveView makes that really easy. Just to give you a real quick and kind of how that works. I've got a handle event for that login form. I get the email, I get the password. And as opposed to immediately taking that and calling Guardian or something to authenticate it, I'm instead looking up inside of CacheX, hey, have I seen this email before? Does it have a back off I'm trying to track? If so, or either way, I take that delay and I assign it to the state. I go ahead and sign the email and password and hold on to those. And again, I'm now from the server side dictating the timeline that the user is going to see. So I'm saying, okay, you're going to delay 4 seconds. There's nothing the user can do about that. And so there's a bit of extra security here. In that like I said, it's all server side driven. They can't edit anything that's going to force the messages that I'm sending from my process to itself effectively in the send after. What order those come in, what their content is, I'm still in complete control of this. And basically I just, from that, using process send after, I can send to myself a message called delay. And I do this just to make sure if you have 0, it just happens immediately. The handle info gets delay. If delay is more than 1, it just sends itself another message in another second and it decrements delay. And basically it's just counting down that delay. And in fact, because it's counting that down, I'm actually taking that delay assignment and showing it to the user. So the user sees I've got 3 seconds left. I've got 2 seconds left. And finally, if we get past where the delay is not greater than 0 anymore, we do this really secure thing where I check to see if it's exactly 1, 2, 3, 4, 5, because that's all the users have the same password in this awesome security system. And if so, great, I create a token. We actually do send it, and this is we're still working on how exactly to make this work. Basically, we're telling JavaScript to go ahead and store the session. One thing you don't get in LiveView is access to write cookies, for instance. So we're doing some little bit of magic there. But otherwise, if it's not correct, if they get any other password besides the only true password, we go ahead and update their delay. They're going to get the next time by 2. So we're just multiplying that delay. So that's that exponential back off. And then we assign delay back to 0, so they get a chance to enter their password again. Any questions about those before we go on? Sorry, I might be moving a bit fast. Okay.
So actually, I'm pretty new to the whole Elixir and LiveView thing. So my question, handle info is generally, I mean, I'm just trying to understand this. And then handle info comes from Gen server, right? So this is like LiveView is, are you including the behavior of Gen server here just to make this happen, or is it already included?
It's included in LiveView. Yeah, it's
okay.
part of LiveView. So every LiveView is it's a process, but they went ahead and included a lot of that Gen server as well. I think they may include the behavior inside LiveView. I'm including the LiveView behavior basically.
I see. Okay. Thanks.
Okay. So the third one is something that comes up. Actually, we've run into a lot more, and I think it happens a lot. The situation where loading information into a view that might take longer than the user wants to wait for that to load in. And there's a lot of different things that could be. It could be a long-running database query. It could be reaching out to so maybe you pull everything from Postgres, but you're also doing an Elasticsearch that's going to take a little bit longer. And maybe a call to an external API. In this case, that's what we're going to show is using a call to a weather API. Really, we want the user to know something's happening, but maybe we want to interact with the page as well. In fact, on this page, this completely unrealistic, there's an unrelated interaction, very clearly labeled. And basically, I want these to be able to click that, and it'll just increment that counter, right? So real basic interaction that we're capturing. And there's actually, I mean, we'll go through kind of 3 ways you can do this. The first is the most basic, and maybe not the best. Basically, when I mount the weather live, I'm going to go ahead and fetch right then. So this is if your controller is going ahead and getting all information before it returns to the user. The user's not going to see anything until I actually get this response from that weather API. This is what you would not do. So I load the page, takes a while, and I've got a proxy that's adding 3 seconds to this behind the scenes. So that's what's going to hopefully cause more time. If I refresh, for instance, can't do anything on the page. It's just going to sit there and not load the whole page. Eventually it'll get there, but the whole page was blocked waiting for this one call. That's the way not to do it. The next iteration of that would be we visit send after again, and when I mount the live view, I go ahead and send myself a message. So I put a message in my mailbox. This processes mailbox to fetch the temperature. So I know it's not going to run that code. It's not going to run that handle info until after mount's complete. Realize that, like we were saying, it's a gen server behind the scenes. Gen server is going to run each of these handlers or handle each message in sequence until it's done, then work on the next one. You're never going to get a point in time where two lines of code in the same process are going to run at the same time. And so here we're just going to send myself a message that says, hey, in 1 millisecond, which is effectively now, go ahead and start fetching the temperature. So we would expect that mount would finish, it would display the page, but then it would load that temperature information and then eventually fill in that section on the page. And sure enough, I did it here. If I go to async, that's exactly what happens. It loads the page and it's running everything and it's rendered the page fine. It's showing it as loading, then it loads it. The only problem with this is that inside of that handle info, I can't do anything else with the page. So if I load this and I click on click me, nothing happens. In fact, I can keep clicking on it and eventually I get a whole bunch of numbers. The reason is LiveView my clicking on the button is sending more and more messages in the mailbox of that process. In fact, 22 messages were sent in the mailbox before the temperature finished, and it couldn't do anything with those. Those were just piling up in the mailbox. This is a really wonderful thing that we get from OTP is that we can, or from Erlang processes, is we can do this safely. I know these messages will eventually get there. They will eventually be processed. But from a user perspective, they're not sure why can't I click on this while you're loading this temperature?
I have some questions. So you try to use a task for doing some async to do, like get this temperature, it's sent for your handle info and refresh your page and update the temperature and liberate for your web browser for you can click and count, something like that, like a way for more like a tuple with continue in OTP when we use gen server. I think this could be figured out. I don't know.
Yeah. And there are a few, and so really the right way, I'll show you the right way now, which will probably answer your question, which is there's no reason that this process, so we're sitting here waiting for this. There's no reason this process has to be the process that's doing the IO, right? So there is a library for doing HTTP called Mint, and Mint does probably what we should be doing, which is I can make a request on my process. Mint will then handle the IO with the HTTP server on the other side, and instead send me a message, or this process a message every time it gets new data, which means the IO is not happening in the process that the user doesn't need to happen there. And instead, Mint is going to send that information. So here, and that we're going to start request immediately. There's no cost to it. Typically, you would have a pool of these connections. You wouldn't really connect the connection every time, but for sake of demonstration, I connect to the server. I send this HTTP request, and I hold on to this connection and the reference that Mint gives me, and I'm done. So my start request doesn't take any time. It's just a matter of sending this data off. And then eventually, Mint does come back and starts handing me messages. Now, the Mint, it's kind of difficult. I mean, it's not straightforward to handle those. It basically hands you a message. You turn that into a set of responses. You have to keep track of the connection because Mint operates statelessly, so you're having to constantly keep the connection. But I'm able to, this doesn't actually take any time. This is just computation, no IO, which means that the live view is not stalling, waiting for that IO. It's only getting notified when that thing changed. So if I load that up here, you'll see if I go to this one, I can do whatever I want while it's loading. It's not waiting on this process. This process has anything to do with that IO. And this is not just for something like HTTP. There's other reasons why you would potentially send a message if you're doing, So you have a queuing system like a RabbitMQ or something behind the scenes where you're doing these asynchronous jobs. You can potentially send a job off and wait or register this process of the receiver of the response for that job, for instance. Lots of times when you might have an asynchronous process that, because this page has a PID and has something that I can hand to somebody else going to call it back, I can do all of this without having to re-engineer how I do the asynchronous part, or you drop in a JavaScript or anything else you might do otherwise. And in fact, this might work as well. For instance, here I'm actually loading I've got it going through a Toxa proxy, which is like a little Docker container that slows down my speed substantially. But here I'm loading a book from Project Gutenberg. And sure enough, while it's loading, because each time you're seeing new text come through, it's just meant calling my PID with the new message, me processing it and updating the LiveView state. I can still do whatever I want while that's loading, all within the same LiveView. Okay, so that's 3. Oliver, you okay on time for? I guess we can keep going. So last one. This is the last interaction we've really been working on.
Yeah, sorry, pal.
Yep. I realized I asked you that, then I realized I also have a clock because my computer's here too. The last interaction, really something it already kind of exists in one incarnation, at least within Phoenix and LiveView, and that's kind of that flash message. The issue we're run into is if we're embedding LiveViews within LiveViews, the flash doesn't actually work its way up to the top. It's the flash only stays in the LiveView that it's in. So there's no way to trigger that global flash, which is fine. It's kind of a product of the way that LiveView structures those processes. But here's a very contrived example. Effectively, we have a toast we put inside the live, that template that we use, the layout template we use for all of our live views. I've got a parent live view, a child live view inside that. And when I hit this button or complete the form or whatever that is within that child live view, I want the top level toast, in this case, to pop down and then come back up. But I want to be able to do that from any child view within live view. As far as I've been able to tell, there really isn't a straightforward way to get the PID of a specific live view. So in the best case, I could ask, hey, I've got somewhere within this view that the user's looking at, I've got a live view of, from the Toast Live module, what's its PID? There's no way to do that today that we can find. Could be wrong. So what we ended up doing was building a little local registry. What we do know we can get from the socket is when every live view that's handed a socket object or socket state within the tree the user's looking at does have the PID under a field called root PID, and it's the PID of your basically your parent or your it's not really root because there's other roots as well, but it's the highest level live view that's rendering all these child live views. And so in this case, parent live is what I'm calling as my main live view that I'm looking at that embeds this child live. It has a PID called root PID, and every live view that's rendered within that parent live view gets that PID in that root PID position. So in the live.html, so our live view template, all we do is render this toast live. So every view gets this rendered before we render the whatever the rest of the inner context, everything else. When Toast Live mounts, it actually registers itself with this Toast registry. So we have a supervised gen server running supervised by the main application and an ETS table. And so we take that socket, take the root PID out of the socket, and we basically say, hey, this root PID, in this root PID, this is the PID of the toast that's being shown to that specific user. We also do the opposite you'll see why later, because we need to be able to find the toast from or the opposite direction as well. We monitor, again, you'll see why. But basically, Toast Live calls register. Register says, hey, I've got a Toast Live. It's in this, it's attached to this root PID. And from then on, if anything else toasts, so for instance, if my button has a handle event, I can call toast, and we do an import just to make it a little bit easier. Pass it the socket, and the message I want, the toast registry looks up for the toast PID for the root PID that's in that same socket, because it knows those are the same, and sends the message toast to that PID, to that toast live. Toast live has a handle info, just does real simple, puts the content on the view, does a little send after so it can hide when it's done. And that's it. And so if we look at it real quick, I'm still loading this novel. Hold on. So real simple, this is my parent view. I've got a child view with just a make toast button. I hit that and I get toast. And that's it. It's a real simple user interaction. But the nice thing is I know that it doesn't matter when we build these components, these LiveView components, they don't need to know anything about their parent. They know they can always call toast, and the more general application will know what to do with that, will know how to call that PID and actually send that information. And lastly, if remember we put the monitor, so that toast registry is actually monitoring the PID of every toast live that's talked to it. So when toast live, when that live view goes away, the user navigates away or it crashes, whatever, it knows to take it out of the ETS table. And therefore it doesn't keep that table too full of old dead PIDs. I think that's all we have here. I will say a couple things that we've noticed. This is my plug for not my GitHub, not my repo. Don't have anything to do with it except we use it and it's been awesome. Imsareva's Surface library, which lets you do a little more on the LiveView components. But behind the scenes, they're acting the same exact way as what you see just when we're actually writing the HTML inside of those live views, it shrinks it a bunch. Let's see. I think that's it. I guess the only thing I was going to show one more thing, or we've got the toast up, and I'll have to change over real quick to. Let's see. Let's see if it'll let me do this. There we go. Can you guys see the observer window? So when I talked before about being able to introspect those states, a couple of things we can do. One is I actually can find inside of here, you can walk it down a little bit to find the endpoint. After that, it gets a little muddied as to which PID is which, but I've got a spitting out. So I happen to know the PID for the toast, for instance, is 841. I can see its state, and more importantly, oh, well, now I realize you won't be able to see. You'll have to trust me if the toast comes up, because I can't. Let me see if I can share both real quick. So I can go into here, for instance, send a message, and send it toast foo. And let me switch back real quick so you can see it. And if I send that message, you'll actually see it come up. So again, the point being, it's just a process. It's got a PID. I can send messages to it. I can handle those messages. And the other kind of stuff around it is just being able to find out which one it was. And I think that's it. Hopefully that was helpful. Some things hopefully you guys haven't seen before in LiveView, or maybe just a different way to think about it. But happy to answer any questions, or go back and dig a little more into it if you guys are interested.
Awesome, thank you. Powell, have you tried doing the toast stuff with like a send update?
Yeah, because I think you can do it with, if you do things with components. So I believe, if I'm not mistaken, send update is components.
Yeah.
But if you have different live views, there doesn't seem to, and even if you look at the, I thought I had a slide in there with the, I just didn't put in there with the, what observer looks like in LiveView. There isn't, you would kind of think you would have that structure, but there's some other mechanism there that I'm not smart enough to figure out as to how it's linking all of those. My assumption is with the channel, and actually if you dug into it, you could probably find the channel you're on and use that. And I don't think root PID is necessarily the be all end all way to do it. I will say we did one way with pub sub, which was kind of not the smartest way to do it, but it got it done because I could just make something up, subscribe to it. That did mean that every toast was being blasted to every node in the cluster. So not awesome. This way seems to be more elegant. And again, with the monitoring and everything, it makes it feels like feels simpler than it should be.
Yeah.
Yeah, I wouldn't be surprised if there's some way with an OTP or with an LiveView that we're missing on how to exactly do that. It looks like there's supposed to be an ID. I know I can get an ID from the socket, but that's still the ID of I think it's the ID of the LiveView that I'm attached to. So if I'm a component on the LiveView in a LiveView, I'm getting the ID of the LiveView that I'm inside that LiveView. I'm getting its own ID, like the ID you pass when you live render.
Yeah, you can get the parent too. You can if you're a component, you get the parent. But yeah, that's awesome. Thank you.
Cool. Let's check with Josh real fast.
Hey, I have the question. Is the code in the slides posted anywhere?
I will. I will clean up my failed experiments in there, and then I'll post it.
Thank you.
And if I don't, feel free to spam me on Slack to remind me to. But I'll try to get up there, hopefully today.
Let's see, one last thing. I'm not sure.
Are any of you guys using LiveView in production?
You can't hear me.
I kind of am. That's why I asked the toast question, because I do something similar. It's not that sophisticated though.
What do you think of it?
LiveView overall is incredible. I did almost exactly the same thing as your kind of wizard thing earlier. And it's enormously smaller than things I've done in Rails in the past, and easier to work with. So I've been very pleased so far, but I haven't done it in like any large system. So I don't have, that breadth of experience yet.
I must say that coming from React, doing wizards and toasts, they have so much more boilerplate than what you've been showing here. But that I think it's a great solution.
OTP good.
We've tried. In fact, the original entrance into that Surface repository was we were trying to get like a component library like you would have in React. I think that was more complex than we needed to do. In the end, we actually do have a component library now based on Bulma, so you can use the Bulma CSS. All of those are implemented in that. There are a couple of things like wormholing. Doesn't have any kind of support. That kind of what I originally did. The toast stuff was actually sort of a wormhole, but it's not as straightforward as like Ember's wormhole or things like that. There are a few other things, but the nice thing is you only have one state to worry about. You don't have to worry about reconstructing the front end and then operating off of it, which just not knowing that what's going to happen, like you're controlling what happens to the user. All those events have to pass to the back end. It's a lot less cognitive load on some of the security stuff and some of the other things you have to worry about.
Have you seen some integrations about live views on Toast and Wizards and React? Like like mixed front ends?
I haven't seen it yet. I'm not sure. I mean, we'll never get to the point where we don't need JavaScript. We still, I mean, in here, there's some JavaScript for doing the login and things like that. And it is very simplistic. I haven't needed it to be more complex than it is. So the way the hooks work, generally that's enough. But at some point in time, and there's also a bit of an organizational thing that there is benefit to having a team that's responsible for the front end, a team that's responsible for the back end. So I can see in some organizations that the idea of compressing all in one skill set might not scale as well for those organizations. I think you can always scale that, but their organizations, maybe that wouldn't work as well. I'm trying to get a front end developer to work with us that basically tell them, like, look, this is still front end. You're still doing front end code. There's still CSS. There's all stuff you're used to. You're just doing Elixir in the front end. I think there's some real benefits to that from a team perspective, benefits that for an empathy perspective, definitely. But
in fairness, learning Elixir is easier than learning Webpack.
Yeah. Yes.
Any other questions? All right. So, hey, thanks very much, Powell, for sharing this with us. It was great.
Thanks for the opportunity. Appreciate it.
We have the giveaways. Before I get into that, I will remind everyone, when you tell other people that Birmingham Elixir exists, the catchphrase is, it's like the Austin city limits of Elixir meetups. So just spread that far and wide. All right. Kevin wrote some Elixir code that ran through a CSV dump of our type form. Real sophisticated stuff here, and randomly picked 3 people. So the 3 people, and I'm going to go in order, and you get to pick which thing you want until we're out of the one thing we only have one of. Santiago, Herminio, and Greg Vaughn won. So Santiago, would you like the book or the ElixirConf EU ticket?
Hello, everyone. I think I would like the book. Because,
awesome.
Yes, I'm just starting to learn Elixir, and I think it will fit my necessities.
All right, that means that Herminio and Greg Vaughn both get to choose between one of 2 ElixirConf EU tickets that are fungible, so we won't go through that process. So you should be receiving an email. So the book, we're going to share your email with Lance, who is going to give it to the people over there that should send you a coupon to get the ebook for nothing. And then the ElixirConf EU tickets, Oliver will be coordinating sending those out. It starts tomorrow, so he's going to have to hustle tonight to get them out. I'm going to be making sure I get those email addresses to him so he doesn't have to go looking.
Just to remind everyone, it's 1 p.m. CEST, so it works fairly well with, as well as it can with US overlap. It's not as bad as it could.
Cool. Josh, do we have anything else? I think if not, that concludes Birmingham Elixir for the evening.
That's it. I got nothing.
All right. Well, yeah, thanks everyone for coming. And thanks again, Powell, for your time. Great talk and good content. And it's good to see everyone. Hope to see you again next time.
And the link to the recording will be posted on the meetup?
Yes. We'll make sure that we post it in the meetup.
Okay. Thank you.
Cool. Thank you, everyone.
Okay.
Thank you.
Oh, one other thing, Kevin, you want to do a speaker next? Bruce is next month.
Bruce is next month.
Oh, nice.
And then after that, we have Steve Bussey. So Bruce will continue his talk from the previous times, more LiveView. And then Steve Bussey will talk about monoliths and Elixir. So it'll be kind of a change of topic then.
Yeah. Steve's also actually part of ElixirConf EU tomorrow now, and is a software architect over at Sales Loft.
Is that the same talk that was in the ElixirConf like the monolith talk?
Yes, it'll be similar.
Okay.
All right, everyone. Thank you.
Thanks, everyone. Thanks, Powell.
Great
Thanks a
meetup.
lot.
Thanks.
Thanks so much.
Thank you. Thank you, everybody.
Bye.
Bye.
See you all. Everyone stays on to see who's left.